Oh, gentlemen, I offer my excuses for not really posting anything, but I have had my reasons. I have had a few issues that I had to deal with. One literally before I could post because my PC crapped out, and the rest were just of a higher priority than dealing with recording and projects. But I have a new machine to showcase, and this one will actually most likely be the first one to be fully restored, as I will be building a small shop to your left, and I will populate it with a few machines that will be of use for other machine restoration. And this Weisser universal milling machine, which will be quite the comprehensive project, will be quite useful. Not extremely because the limited travels, but at the same time, unless you have a bedway grinder, you're not really going to be able to use any of the machines for proper machine restorations. And I don't have the space for a whole full-sized bedway grinder. When I was offered a mill at the scrapyard, I had no idea what the machine was. I just took a quick peek at the machine, only to notice a Weisser fine script writing cast into the machine. But yeah, I saw the Weisser writing, and I was quite unable to resist the machine, despite the rust damage, despite the ice damage, which is much worse than the rust damage, but at the same time it's in a non-crucial area that can easily be restored with no consequences to machine geometry or structural integrity. A backside of the third coolant sump, essentially a separate bolt-on coolant tank, got its backside blown out. I have the piece over here underneath the bottle of the WD-40, so it can just be ground off and braced back into place, filed into shape, repainted, and eventually recast, because it's a nice pattern for mold making. It's essentially just a square cup with a flange. I have fiddled a bit with the machine so far, not too much. I was hoping that I could use a wheel hub from a van as a head carrier, because it would allow me to integrate two crescent ears, which would socket around this, or slot around this rectangular section of the Z-axis. The dovetail extends from over here, but this is a square or rectangular section. By square I mean that the shoulder that goes into the machine has a... You get the point, you can see it, for fuck's sakes. The wheel hub had the perfect bolt hole pattern. It was a 10-hole pattern, which had a perfect geometry for these 4 bolts, or rather what would have been studs, that will hopefully pass through the machine. I'm not sure if the threads can pass through the machine, because that would be nice, as it would allow me to use large flanged nuts with washers from within the machine to enlarge the bearing area of each screw, rather than having it rely on the threads themselves. But that won't be happening, because the bearings in it are integral. The outer race is integral to the whole cast wheel hub, so I can get stuffed essentially by turning down the bearing geometry after knocking the bearings out. I would be left with minimal material for head bearing, and I wanted to integrate a needle bearing in it at the front, so it would essentially protrude and the head would be mounted to it. The spindle would of course and will of course be remachined into, I'm hoping to remachine it into ISO 40. As you can see, the spindle is too small for an ISO 40 at the nose, but the spindle... Nah, I'm not sure. I was hoping that the spindle may be coned out, so I could face down this section, and I have drained the coolant, or what was remaining from it. I extracted some junk from the sump. I will show it to you. I'll show you the table. I'll maybe slightly brush it and start cleaning it off. But essentially, as you can see it, that's the whole mill and everything that came with it. These two panels were removed from the top. This rotary table fixture that's lacking the top piece will make it a separate project. I will not mind a nice rotary grinding fixture, because this is definitely not a milling fixture. It's way too unskookum for milling purposes. As you can see, I'll have to integrate a glass lens into this section over here, because I want the table to protrude all the way to here. I will remove the stops, and I will need a lens to see the scale to make use of it. But so that's the table. Yeah, the machine is quite cool. The spindle is driven through a CVT transmission, which allows seamless 65 to 2000 RPM speed change. The table is hand wheel driven, but it is also hand wheel rack, for fuck's sakes, screw driven, but it is also rack driven. I was not wrong when I said rack. I just skipped the order of things. You can see the rack over here, I believe. Yeah, you can actually see the rack, which is quite a rare feature. Most mills do not have rack-driven tables. They maybe have a rack-assisted ram movement, or certain rotary joints can be, well, it's not really a rack, then it's a worm and gear assisted movement, but it's sort of a rack. The table lubrication is a horror of a design. It uses two screws that you drip feed oil through, so it allows junk to fall into the lubrication area from the threads when you remove the screws, but we'll deal with that in time. Presently, I just want to clean up the machine a bit. I'll start with a bit of petrol. I know that you haven't seen the condition over here, but you need not see it. It's just disgustingly dirty. I'm using a steel wire, as you can see, as that is least abrasive. The hardness of the steel should be lesser than that of the table surface, so the most abrasive element of this whole setup should be the rust itself. That's just off-brand WD-40. The table actually does have some slight molestation to it. I just noticed in the corner over here and a few dings, but well, not pristine. I do not really mind. It's for the most part beautifully preserved since 1955. So the machine has been covered in a thinned down solution of what do you call it? Graphite grease, the axle grease, and ATF as a thinning agent. Okay, the table will need quite some work. Everything will need quite some work, but I'll just try hand holding a brass brush and seeing how far that gets us. I'll have to use it in a drill and zip all over it because handheld variant will not do. I have some decent brass brushes, so that will do nicely. I will not be using steel brushes on the table. I'll use them in here in the sump, but the axes will be restored with minimal impact to the current material conditions, and the current geometry actually is the more important thing, because I want to see the state of the machine, the general condition, once everything is cleaned up nicely. I'm just cleaning out the threads so no junk gets dumped, or at least as little of it gets dumped into the hole. I'm just moving it inside the backlash range. Yeah. Fuck. Okay, that's one. We have another here. I will most likely drill a hole from below and add a pressurized central lubricating system to the, how do you call it, this bearing retainer assembly. This section I'm not sure how it will be attended to, but I'll have to deal with that. This oil drip feeding system is not an option. Uh-huh. That one still. tool. I have a theory, but I'll not get into speculating at the moment. Okay, I'll show you the machine a bit closer up, and I'll wrap it for today. I have some gardening to do. Here you go. Sorry for the handheld, but yeah, you cannot really see shit from the reflection. This is as good as it gets. It looks worse in these rusted sections. I'm sorry, no fingers. Like this section here, due to the reflections again. But oh yeah, this is the apprentice mark that I mentioned. And of course I touched the fucking oil. How would I not? But yeah, this is the apprentice mark. This is one of the dings. Another is over here. And that's pretty much it. There is another small ding over here, but those can be stoned out and completely ignored. This appears to be a dry spot for some reason. It probably got soaked with something, mouse piss or something like that at some point. So it'll have to be scrubbed off. The gearbox, as you can see, has a telescoping feed from the main body of the machine. The dovetail of the x-axis does not appear to be in a terrible condition from what you can see over here, but still, until I attend to it, I do not want to move it. The gear is missing over here for the rack, as well as you can see. That'll have to be sorted out. This is the y-axis stop slot, as you can see. This T-slot over here does not probably offer any stops for the z-axis, although it could with this protruding section. Yet that looks like a table clamp more than a stop, hard shoulder, or however one would call it, registry point. And using stops on the z-axis would tilt the whole assembly slightly, given that it would be actuated just on one side. This handle you have seen, the insides are clearing out. The gibs are interesting. The x-axis has a regular screw tightened, or rather actuated, as you can see from here, tapered gib, but this is a different kind of a tapered gib, more of a trapezoidal shape, and the same applies to this one over here that is pulled by these large fasteners. The ram over here is quite fucked with rust. You cannot really see it, but it is. I'll have to loosen that, I'm sorry. The spindle nose, as said, will have to be remachined into something else, because this Morse Taper 3 with a rectangular drive dog configuration does not suit my needs nor purposes. I would prefer having a ISO 40, because my Shoblin 22 uses ISO 40, so the tooling would be interchangeable, but we'll get to that. And the head that I'll have to remake, I'll maybe try using something like, you can see a bit of it underneath this huge cast iron surface table, a tractor weight that is a large piece of cast iron that is yay tall, some 14 centimeters or something like that. I'm not sure. probably around 14 because it fits underneath the broken pallet. Yeah, I'll have to machine that, plop that onto the machine body. I'll probably machine in those wings for it to register against the sides over here, and I'll give it tapered gibs in brass or bronze, I'm not sure. Either would do. Soft gibs are good enough because once this is cleaned off, it's just a hard registry surface. I'm sorry for the framing and focus. And maybe I could apply another identical weight, but turned the other way, so they make a, how would you call it, a concave geometry in between them, or rather from the side, like this. They would be concave, and unfortunately it would be a swiveling configuration, but I do not have a large enough piece of material that I could machine a solid head out of that would have all the features that I need and all the spacing for the bevel gears and everything. Yet those two pieces would offer a really nice head that would protrude somewhere to here, let's say to here, which is a bit much, but the spindle would be at the same time here, which allows for most of the y-axis movement. Yeah, it would be actually perfect. I'll have to see. I'll have to see. At the moment, everything is just speculation and plans. The ice damage that I talked of, you can see over here. This whole section has been blown out. That can be easily restored by brazing and recasting eventually. The CVT wheel that I will not be actuating because the belts are perished is over here. The glass will have to be cleaned and polished out. I'll have to open this gearbox over here because I believe that it has two large and a small gear that you can swap around to achieve this large, small, small, large configuration from the speeds and feeds plate. This is 2000, this is 65, you can see. There you go. Yeah, oh, let me just show you this nameplate. It's as much information as I have on the machine. Apart from that, I really have nothing to go by. There are absolutely no pictures or even a single trace of such a machine ever having had existed, other than a few photos of the Weisser's 1920s or something around that time period in factory catalog that depicts some of their own machine-making machinery. But those machines are not identical to this one, and their knees are not identical to this one. However, they do look quite similar. So one could say a prototype, an in-house prototype. The tank drains over here, drains under, which is a stupid design. It should flow over. And from there it separates into this rat hole over here that you can see that passes over here through the casting underneath this piece there, through this integral pipe essentially into the third tank. So it's quite a complex system. I'm not really sure why. What were they trying to achieve with it, given that all the junk can just bypass over here and flow over there. But at any rate, you drain some of the junk over here, and it also acts as a lifting feature. That piece, you have the ear over here, which is a large lid for the spindle oil tank, and another ear over here. You just let's not explain the geometry, how you wind the rope around it. You use a large enough endless rope and voila, the machine lifts quite nicely and it's perfectly stable. So that's nice. Yeah, I'll pretty much shut up. I know that I have said nothing really smart and that I haven't really showed you much, but at the same time this is just an announcement video. I have some work to do, and I'll get to some more work around this machine eventually, so well, quite soon, but not today as said. So I'll bid you all the best, and until I actually get to some work, or at least explanations of designs that I have drafted for certain features of this machine. This hand wheel that's missing for the gear actuation is one of the designs. Yeah, until then, all the best and bye-bye.
One day later.